we explain the volume for saturated soil and the weight for saturated soil. We have this now. Okay, let's see the previous relationship, what they looks like for a saturated soil. Then the relationship of saturated unit weight, we use gamma SAT to represent it. This is saturated unit weight. To avoid the ratio moisture content and specific gravity of solids is, this is easy, right? So for the saturated unit weight, the total weight now is the sum of solids and water, right? And in here, V equals to this, right? And WS is this, WW is this. So we have this. Why? Because you can write the up part in here. If they have the same parameter, gamma W, right? Then you can write this into here. So this is why we got this. And because saturation degree equals to 1, we explained this, right? For saturated soil, saturation degree equals to 1. So the void ratio equals to the products of water content and the specific gravity. This is a unit weight for saturated soil and void ratio for saturated soil. And if we consider a soil that has a total volume weight of 1, this is what, if we think that the total volume is 1, why we do this? I said, we think about, we do it in this way, it's just to simplify the derivation steps. It doesn't matter if it is 1 or another number. So we have porosity. What's the porosity? Porosity, we say that porosity is just another parameter to account for voids, right? We have void ratio equals to VV divided VS, but porosity is the VV divided the total volume. The difference is between here. So actually there is absolutely a relationship between void ratio and N, right? Because right? Oh, no, sorry. Right? This is right? So solids of volume. Volume of solids equals to the total volume minus the void's volume, right? So we can write a void ratio like this. And if we put it in this side, we have this, right? Again, so finally, we can write that if we divided this, so from here it is easy, right? It is still clear. If we divide the VV in both sides, that is E V, or we divide the V in this side. It should equals to this, right? What is this? So what is this part? This part is N, right? So that is E N. So N equals to, we have this. This is just tells you that for porosity and void ratios, there are always a relationship or a parameter about void volume. So they absolutely can transfer between each other. Yes? Oh, sorry. So then it is N. It should be like this. And finally, if you write it over, it is like this. We have the derivation steps in our textbook. So it just tells you that we have relationship between N and E because they are all from the void volume. It's just that the bottom part is different, but they can transform. So, if we say V is 1, then V equals to N because N equals to this, right? V is now is 1, so V is N. Then we have Vs is 1 minus N, right? Because Vs equals to V, the total volume, minus the void volume, right? So we have this. The weight of soil solids and weight of water then becomes to this. Weight of solids. Yes, it becomes to this. And weight of water is this. Here is a little bit complex. Anyway, you may a little bit confused in here because we have this, right? And why we have this again? Because when we derived this equation, we think that the volume of solids equals to 1. The volume of solids equals to 1 in here. You multiply on 1, so it is this. But in this equation, the solids volume now is 1 minus N. This is why weight, weight, unit weight, and volume. Then you got the solids weight because the volume change. This is why it changed because we considered a solid that has a total volume V equals to 1. In the previous equation, we It's just help to derive those equations. For example, if you know void ratio, you can use previous equation. But if you know porosity in here, then you can use this equation to derive Ws. And again, for WW, this is unit weight, and we yes, it is from here, because WW equals to the products of W and solid's weight. Why? Because we say that the very basic weight relationship is right. So we have this stake because Ws equals to here, so we have this. It doesn't matter we consider the solid's volume is 1 or consider the total volume is 1. It's just want to help to derive those equations, to derive those relationships. To derive this relationship is because if you don't have no idea with void ratio, but you know the porosity, then you can use this equation to calculate Ws and WW. But if you have no idea of porosity, but you know void ratio, then you can use this. Okay, so then again, if without a void ratio, we can also based on porosity derive the dry unit weight and unit weight. Are you confused?
Yes.
About what?
Everything is changing.
Yes, it's just some derivations. But the steps is right? Follow me, you find that the steps is right. If it is right, so then we have no problem with the relationship. It's just we've already got some relationships, so you may be a little bit confused. Sometimes we want to derive a relationship, we need to symbolize something. This is why we consider sometimes the voids, solid volume is 1, or sometimes consider the total volume is 1. It's just to try to find an easy way to derive those relationships between voids and weight or unit weight. This. So from previous two equations, we've already know gamma W, gamma S, and the weight of solids and the weight of water, right? From here. So if we want to know the dry unit weight, just consider the weight of solids, and we consider the volume. The total volume now is 1. So the gamma D now equals to this, and the unit weight now, if we consider both solids weight and water weight, so it is equals to this. We don't always use porosity. So this is why I talk about these two relationships very quick. In most of time, we use what? We use void ratio. As I said, yes, of course, the void ratio we have relationship between void ratio and have this relationship between void ratio and porosity. If you know porosity, you can calculate void ratio, or if you know void ratio, you can calculate porosity. But in most cases, we don't use porosity. We use these equations. We use void ratio. We use the void ratio to calculate gamma T. Understand? So, but if you know void ratio, of course, from this relationship, you can derive this. You can derive this. Then let's do one. Then you will clear. So void ratio equals to n divided 1 minus n, right? We write it in here. This is a relationship between void ratio and porosity. I said, as long as you know one, you can derive another one, you can go to another one, because they are all parameters about void volume. So this is a relationship between void ratio and porosity. So now we have gamma D, the relationship between gamma D and the void ratio, right? So how we derived the relationship between gamma D and the porosity based on this? Then we have this, right? It equals to GS gamma D. Right? We just substitute E with this, right? So then you just try to rewrite this stuff. Rewrite, it is a little bit complex. How to rewrite it? What we always do is multiply 1 minus n to the bottom, right? And to the top. Understand this? And then the bottom equals to 1 actually, right? We have minus n and we have plus n. So the bottom equals to 1. So finally we got gamma D equals to this. Right? So from the gamma D, the relationship between gamma d and void ratio, we got the relationship between gamma d and porosity based on this. So then we go, remember here, we go right, it is the same. It is the same. So it's just the relationship between gamma d and porosity. You can always, as long as you know two parameters, one about weight, one about volume, you can derive any other parameters of soil. We not always use porosity, but the void ratio one is the most one adopted. This is a table about all the relationship I cut from a Chinese textbook. So we have the relationship for void ratio, relationship for dry unit weight, relationship for saturated unit weight. Ignore this. This is float unit weight. We don't use it. And the relationship for saturation degree. In our textbook, we use S, but in here, in most cases, or some publications, we usually use SR. And the relationship for porosity. The first column is the very basic, or we say the definition relationship, right? For example, void ratio definition is the ratio between void volume and solid volume, right? Right? And then based on other parameters, we can have some derivation like this. We can have more derivations like this. In most cases, we cannot directly got the volume of voids and the volume of solids is not easy to measure. So this is why we have derivations. Because in laboratory, what you can easily to get is W, water content, you can measure. GS, you can measure. And the void ratio can also be measured, can also be derived. So as long as you know two of them, you can calculate another one. For example, you know gamma D and GS, these two is easy to get. So you know the gamma D and GS, you can calculate void ratio, right? And then with gamma D, GS void ratio, you can calculate, with this equation, you can calculate water content. And again, you go to water content, you can go to a lot of other relationships. You can go to calculate many other parameters. So this is why we have those derivations, because with definition, you can never directly go to those important parameters. This is why we have derivations. What?
Those derivations, we necessarily have to multiply partials, right?
What?
We have to memorize the derivation.
You don't have to, I said, you don't have to remember this, but it's better, of course, remember everything, it's better to remember everything on the textbook. I think it's not quite necessary because as long as you open a textbook, you can always find those derivations. The main thing in here is just to understand how we got these derivations from the definition and why we have these derivations. Because later, in the following chapters, we will always use these derivations to calculate some other parameters. And if you study for masters, because this is basic thing for material, density, volume, those relationship is basic thing for material. So you don't have to remember it, but to know how to, some very basic way. But you don't have to remember it, but later, if you use it again and again, you will remember it. You will keep it in mind. For example, this one, we use a lot, and we use this a lot. And also, yeah, this two is that is this one. These are some most used one. And I will give you the PowerPoint. For homework, you will always use those relationships, and for your examination, I'll post this table on the examination paper. So again, you don't have to remember it. Fine, we stopped here, and in next class we finish chapter 3 and give you some examples how to use this relationship to analyze, and then give you homework in chapter 3. So now submit your homework in chapter 2, please. If I have class for undergraduates or Chinese undergraduates. So you guys give me your notebook. How can you work for? So you give me this, and you hope me that I give you back. I'm sorry I can't do this because the university asks some records for your homework. So I can post how much you got for your homework, but I can't give you your homework.
Well,
Okay?
asking is pretty here.
Can I take it out? Or now, please, if you submit